Hello everyone, in this session we're going to learn about logic, especially symbolic logic. At the end of the lesson, the student can define and identify statements, define the logical connectives, write statements in symbolic form, and construct the truth tables for compound statements. Our first lesson is all about the basic terms in symbolic logic. What is logic? Logic is a branch of science that studies correct forms of reasoning. It plays a fundamental role in such disciplines as philosophy, mathematics, and computer science. Logic, the study of correct reasoning, especially as it involves the drawing of inferences. Symbolic logic is by far the simplest kind of logic. It is a great time saver in argumentation. Additionally, it helps prevent logical confusion. The modern development began with George Boole in the 19th century. Symbolic logic can be thought of as a simple and flexible shorthand. Let us now familiarize ourselves with the basic term in logic, and that is proposition or statement. State whether the following is a statement or not. So please try it yourself. You pause this video and try, or you may guess whether the following sentences is considered a statement or proposition in logic. So let's check your guesses or your answers. Number one is not a statement or not a proposition. Number two is not. Number three is also not a proposition. Four is a statement. Five is not. And six is a statement. Why number one, two, three, and five are not considered a statement? And why number four and six are statements? What are their common descriptions or characteristics? So when do we say that a given sentence is a proposition or a statement in logic? As you can see, number one, two, three, and five are not declarative sentences. Four and six are declarative sentences. Even some or one of these is not true, it's false. It can also be considered as a statement because a statement in logic is it should be a declarative sentence and it can be identified or classified as true or as false. Propositions or statements can be thought of the atoms of propositional logic. A statement is a declarative sentence that can be objectively determined to be either true or false, but not both. Try this. State whether the sentence is a statement or not. So you have a minute. You may pause this video and try to answer this exercise. Let's check your work. So for number one, Pamplona is a town of Isabela. That is considered a statement in logic. Even if it is false, it is actually a declarative sentence. So it's a proposition or a statement in logic. Number two, enjoy the day. It's not a statement because it's not a declarative sentence. Number three is a statement. Four is not a statement because it's not a declarative. Instead, it is interrogative. It's a question. And it's not considered a proposition or a statement in logic. Number five, it's not because it's not declarative sentence. It's actually a imperative sentence. And number six, two is an odd number. That is a statement. Even that one is actually a false statement, but it's still a statement in logic. Let us now differentiate simple statement from compound statement. So what is a simple statement? A simple statement contains only one idea. An example is Philippines is named after King Philip II of Spain, while a compound statement is a statement formed by joining two or more simple statements with a connective. You will learn the different connectives later on in logic. An example of a compound statement is John studied for 3 hours and he got a perfect score. An example of connective is the word and you will learn more about this. Let us classify the following statements as simple or compound. Number one is the principal will observe a class on Tuesday or Wednesday. This is compound statement. There is the connective or. Number two, Kabagan is a city. That is a simple statement. 5 is an odd number and 6 is an even number. That's a compound statement because of the word and. If today is Saturday, then tomorrow is Sunday. That is an example of compound statement. The zip code of Tuguegarao is 3500. That is a simple statement. So I hope you know already the difference between simple statement and compound statement. How about quantified statements? Quantified statements involve terms such as all, each, every, no, none, some, there exists, and at least one. The first five, the all, each, every, no, none, are called universal qualifiers because they either include or exclude every element of the universal set. An example is every student taking MMW will pass. So that is actually an example of universal qualifier, every. The latter three, these are some, there exists, at least one, are called existential qualifiers because they claim the existence of something but don't include the entire universal set. An example is some students did not enroll this semester. Some students did not enroll this semester. Let us study the quantified statements and their negations. If we use all, like all x are y, the negation is some x are not y. If we have no x are y, the negation is some x are y. If we have the statement some x are not y, the negation is all x are y. And if the given statement is some x are y, the negation is no x are y. Let us have this practice test. Give the negation of its quantified statements. So you may review the previous slide and try to answer this exercise in a minute. You may pause this video. Let us now check your answers. For number one, what's the negation of the statement, I took a shower today? The negation is, I did not take a shower today. How about my car is red? What's the negation? My car is not red. And how about this statement? All professors in SPUP have cars. The negation is some professors in SPUP do not have cars. And the last one, someone in this class will fail. The negation is no one in this class will fail. I hope the negation will be the true statement. What is negation? Negation of a statement is a corresponding statement with the opposite truth value. The symbol for negation is this or this. If a statement is true, its negation is false, and if a statement is false, its negation is true. And that's all for our first lesson in symbolic logic, the basic terms. If you have any question, clarification, or something to share, you can do that during our synchronous station. Mabalo, stay safe.